Hi guys, welcome to the last chapter of forensics. So we are done for the year after this chapter. So yay, congratulations guys. Thank you for being patient and understanding and flexible during this weird time. I don't know if we're still online at this point. I'm making this video on April 1st, so we shall see. So, but either way guys, thanks for hanging in there, and I'm really, really proud of you. All right, so have to go through the video again, and last thing you guys have is one more assignment, so make sure you get that turned in before before the end of the day, before the end of class. Whatever's listed on the assignment, I can't remember right now. So let's go ahead and get started. This is going to be a very short video. All right, so we're going to talk about trace evidence and how trace evidence is essentially small evidence that gets found at a crime scene, and how we're going to talk about deductive reasoning with the analytical data, how to follow qualitative analytical schemes, and how to gather and solve problems. Okay, we're going to talk about how to identify metals, classify lip prints, use chromatography to compare lipsticks, and so like that. Other experiments we won't be able to do. All right, so trace evidence is physical evidence found in small amounts like hair, fiber, paint chips, body fluids, stains, powders, explosive residue, glass particles, vegetative matter, metal particles, soil. Pretty much anything that's found in small amounts can be considered trace evidence. Okay, a torn piece of paper, some itching powder, ashes, a spider. Depending on the species, that could be extremely important. Match, grease, linoleum, all these things could be considered trace elements, okay, or trace evidence. Physical properties, you guys remember that they don't involve changing the identity of a substance. This is odor, color, the boiling point, density, refractive index. You don't need to actually do anything to the substance. Chemical properties involve changing, or how does it change or react when another substance is added to it. Okay. Metal can be identified based on their physical and chemical properties. If you're looking at solid particles, you can look at them under the microscope. You can apply magnets to them. Some metals are not magnetic. Or how malleable are they? Their density, their color, solubility, and their reactivity. If they're dissolved metals, you want to separate them with chromatography to compare them, the RF values of known metals, to known metals, their specific reactions and color testing. Metal salts can show distinct color when they're heated, and you can use this property for analysis. This is what you'll see in fireworks. The different colors you see are the different metals being used inside the fireworks. All right, so right here, strontium gives a red flame, copper gives kind of like this aqua color, and boron is a kind of a greenish color. Iron is kind of like this yellowish. Sodium is a little orange yellow. Potassium is kind of like a lilac color. Calcium has kind of a reddish orange to it, et cetera, et cetera. Okay, so that's so the color comes from the light that's getting reflected off of it. All right, so case scenario, solid particles metal particles were found in the loaf of bread. Were they from the flour, the manufacturer? Were they introduced by plaintiff for personal reason? The person who said, hey, I found these in there, I'm suing the company. Did they put them in there? That has happened before. So you have to be able to answer those questions. And you want to look at the, what type of metal particles are there? And then you can say, hey, these were the same metal that's found in the machinery where the manufacturer made the flour, or the plaintiff happens to be works with scrap metal and everything, and they have a lot of this metal that they work with. So depending on it, you want to first determine if it's magnetic or not. If it's magnetic, then you want to apply HNO3, and depending on the reaction you get will help identify the metal. If it's not magnetic, you want to put it in bromoform. And when it seeks or floats, you break it down further with NHO3 or sodium hydroxide. Then the reactions go branching down here. So make sure that you look at that. That chart is also found on page 247 in your textbook. All right, qualitative analysis. Yes, qualitative analysis. You know, they can look at the water quality, soil quality, and stuff like that. You know, there was some flooding nearby that was causing crop failure and livestock sickness, so they wanted to test the water quality to make sure that wasn't the problem. Also, sometimes when investigators find substances at the crime scene, they'll need to use different techniques to figure out how to identify the substance. Qualitative analysis is one of them. If you find white powder, well, white powders, lots of white powder substances actually look alike, so you have to run qualitative analysis on them, okay? And first thing you want to do is look at microscopic examination. These are different crystal shapes and structures, so that's distinctive. You want to look at their solubility, their pH, their chemical reactions. What colors do they turn? What precipitates get formed? Is gas formed as a result? Okay. So a historical crime in 1912, Emil Gorbin was a bank clerk and came under suspicion for strangling his girlfriend. He was arrested, but he appeared to have an airtight alibi. Edmund Locard went to his cell and removed scrapings from underneath his fingernails, and they contained tissue that possibly came from his girlfriend's neck, but it was not provable. But Locard noticed the tissue was coated with a pink dust, which was identified as rice starch. One of the particles he found bismuth, magnesium, stearate, zinc oxide, and a reddish iron oxide pigment called Venetian red. They examined the face powder used by the girlfriend, and that powder was prepared for her by a Lyons druggist. It had a similar composition, so they were able to connect him to the murder. However, nowadays, since face powder is mass-produced, it probably wouldn't work as well. But because this was a specially prepared powder, it led to he confessed it. So that's how it can be used. All right. More recent crime, a bank robber was startled by an alarm in 1979 as a teller handed her money. She grabbed it and running away really quickly, she ran smack dab into a glass door. She recovered, got away. Examination of the door, there was red lipstick imprint of the perpetrator's mouth. With the help of the FBI, the police were able to identify a suspect based on the imprint, and they picked up their suspect, but they needed evidence to link her. Are lip prints unique enough to tie the suspect to the crime? The answer is yes. It turned out that it was a man who had dressed up as a woman in order to throw the police off his trail. He was ordered to have a sample lip print to compare to the one left on the door, and was found to be the same, and he was served 10 years in prison. Okay. What they looked at were the matching creases in his lips on both prints, and that can actually work similar to fingerprints. So as you can see, there are different types of lip prints right here. The short vertical lines, cross hatching, short horizontal lines, and branching grooves. Like that. All right, guys, so that's it for Chapter 9. Please make sure that you answer the questions. And again, it's been great, and I'm really, really proud of you. So have a great day and a great summer.